Hi, everybody. My name is Andrea Wilson Vasquez, and I will be talking with you today about equitable and engaging computer science for English learners. Let's go ahead and get started. So I'm an innovative instructional coach at an alternative high school in Intermediate District 287, which is in Minnesota. And I'm also the director of educator training for a nonprofit here in Minnesota called Code Savvy. Just to give you a little background about where I'm coming from with relationship to my experience with English as a second language, I do have my master's in English as a second language and am a licensed ESL teacher. There's a little bit of contact information about me if you'd like to get in touch. So the first question I'd like to throw out there is, where do you keep the catch-up? This is actually a question that some tech companies are asking when they're forming diverse teams to tackle really challenging questions. And what they're finding is that your response to this question can help to show a little bit about your background and kind of your perspectives on things. And that if we choose diverse teams based on kind of common answers to where everyone keeps the catch-up, well, that's not actually going to help us with including a variety of perspectives on challenging questions or challenging issues. Instead, if we base our team makeup on a variety of answer responses from where people keep the catch-up, that can also help as a metaphor for the kinds of tools or the kinds of other ideas that we might reach for if the metaphorical catch-up isn't working or isn't available. So just kind of a funny anecdote to help get us into why diversity in teams is really important and why we really want all learners to have access to computer science education. And I did include a link here below to where I got this question from and a little bit of information about kind of that, where you keep the catch-up as a presence in the tech world. So I'd like to throw an agree-disagree question out there. How do you feel about this? All teachers are language teachers. And I ask this because as we think about computer science, you might think of computer languages, you might think of programming languages, Python, you might think of JavaScript. You might not be thinking about how you teach English as you're working with students. And I really would encourage you to consider that as we're going through the information here today. Some goals for my slides or my presentation here today. Really, I just want to help you gain a background on English learners in education, specifically thinking about computer science. And I'd like to help increase your understanding of language complexities, especially as they relate to computer science, as well as share some strategies for supporting the academic language development for computer science, specifically looking at English learners, but also thinking about how all learners can really benefit from these strategies. So let's just take a quick moment to center ourselves on who K-12 English learners are in the United States. So first off, I want to let you know that there is an average of 10.1% of all K-12 students in each state are English learners. Of course, it varies by state, and this data is from 2017, so it's probably changed slightly by now. But I do think that it's important to think about 1 out of 10 students are learning English in some fashion. In case you were wondering about kind of what is the most widely represented language group within our English learner population, it is Spanish. However, I'm sure as you think about your school and your student populations, Spanish is not the only language represented. There are many others, Arabic and dialects of Chinese being kind of the next runner-ups. In Minnesota, some that we see quite often, specifically thinking about my school, are Somali and Hmong, as well as Spanish. Just an interesting point of reference as we're thinking about English learners, the majority were actually born in the United States and are United States citizens. And so don't necessarily come to us as immigrants, although some do, and refugees. But just thinking about the context that being an English learner and kind of a native-born U.S. citizen, kind of the context and the challenges and benefits that brings with our students. Just to further kind of contextualize the importance for supporting our English learners in computer science and other subjects, the average graduation rate for English learners was 60% in 2015-2016 as compared to 84% for non-English learners. So really anything that we can do to support our English learner students to continue to feel successful in school, continue to make progress towards graduation, as well as be gaining the skills that they need to be successful beyond our schools are really important things. So this probably comes as no surprise that there have been some big changes in the AP CSP exam enrollment. This is data from 2017, 2018. So the total number of AP CSP exam takers, of course, really jumped. And as we look at one group of students, the Hispanic Latinx group, which is one that is called out in the demographics we have available from CSP exam takers, we can see that there was also an increase, but certainly we can also see that the percentage or the representation of Hispanic Latinx students is still very small compared to the overall total. So just thinking about how we can do some really specific outreach to our English learners. And again, not saying that all Hispanic Latinx students are English learners by any means. This was just one data point that I was able to access through the demographics available through APCSP through the College Board. Looking at the passage rates, there was a 61% gain in the number of Hispanic and Latinx students who scored a 3 or higher on the APCSP exam. Again, that's from 2017 and 2018. So good progress being made, but certainly still room to grow. It's just a little bit of further information to show kind of where there's still gaps. The last data point there says that underrepresented minority students have been passing at a rate of 49% in terms of the AP exams, which is 27% lower than the majority students, so white students. So as we're thinking about English learners, what are some considerations to just kind of have in our minds as we're thinking about how to engage students in our classrooms, not just computer science, but across the board. So one thing is that literacy in students' first language plays an important role in how quickly and how confidently students grasp onto new academic concepts in their new language. So if a student has some background and academic kind of experience in their first language, they tend to grasp onto or catch on to new concepts, linguistically speaking, in their new language faster. That's helpful to know as we're thinking about maybe if a student is really struggling to catch on to something. Formal schooling can also be an indicator of how well students will catch on to something or how much support they might need. Some students come to us and have really interrupted formal schooling experiences, especially thinking about refugee students who may have lived in refugee camps or have moved around quite a bit. So there might be gaps that students need help and support to overcome in order to really be able to access the information and concepts in a variety of different classes. Of course, with moving around a lot can also include interrupted EL, English Learner Program involvement and support. So not only might they have gaps in academic understanding, but also in English language proficiency. Some students continue to move around a lot, of course, and so wanting to be really supportive of the students while we have them. Also acknowledging that some of our students might not be documented immigrants and some of their families might not have proper documentation, which can lead to some really unsettling feelings and feelings of insecurity or of being scared, especially related to the police and other things. Some students that I have worked with, especially in the high school setting, are getting close to being 21 years old. And so think about how they can really make quick progress towards graduation before they age out of the high school kind of age frame. And then finally, what is the student's academic language experience like? Have they had a lot of input in English related to academic language? Have they had a lot of input in their home language related to academic language? And then how are they doing with output? Have they had a lot of experience and exposure to producing that academic language? So one of the foremost researchers in academic language is Jeff Sweers. And I thought this quote was especially important when thinking about computer science and how we want to make sure that our content and language is accessible to all students. So it talks about how academic language is often cited as one of the key factors affecting the achievement gap that we see between kind of our high and low performing students. So if we're looking at how do we bridge that achievement gap, academic language can be one possible way. Of course, I mentioned at the beginning that not only our English learners can benefit from having exposure and support to academic language. Think about learners whose language and dialects at home do not necessarily mirror the language we speak at school. So students who use African American vernacular English, students whose families are English learners, but maybe the student is a native English speaker themselves, others who have had kind of some different exposures to a variety of different dialects. And like I said, just maybe their home language doesn't mirror the language that is spoken in schools. So as we're thinking about kind of the kinds of language that are out there, one important kind of point to make with regards to English learners is that there are two kinds of levels of English that students gain proficiency in. The first level is related to social language and is often called BICS, Basic Interpersonal Communication Skills. And it's often cited that BICS take about 1 to 3 years for students to gain proficiency in. This is really just the surface level language. This is the hi, how are you, kind of the face-to-face conversation, the highest frequency vocabulary words, simple sentence structure, kind of the low pressure social situations. This is thought of as the tip of the iceberg or the top of the iceberg, which is how this visual comes into play. When we think about academic language, that's more of a longer standing or longer process to develop. So that can take up to not up to, but starting from 5 and beyond years to develop. And it's called cognitive academic language proficiency. And it's not just thinking about like the most complex vocabulary, although of course that is important, but also thinking about how culture comes into play when we're understanding different pieces of language, different stories, understanding how humor can carry so much context and carry different meanings to different words, and how that can take a while to develop and understand. Of course, things like textbook language come into play here. Think about words that are abstract or concepts that are really abstract and how those can be really hard to describe and understand. This is kind of that lower part of the iceberg that takes more time for students to develop and really is more high stakes. So there's more pressure involved in using and then understanding this kinds of language. This research comes from Jim Cummins out of the University of Toronto. To give you some further perspective on social versus academic language, here's another chart that I think is helpful in describing kind of the overall ways that you would see social and academic language showing up, how long it takes a learner to acquire these or develop proficiency in these, and then some examples. So things like writing a post on Facebook, texting, having an informal conversation, those can be examples of social language, whereas more defining a scientific term, describing a classic work of art, explaining how to solve a complex math problem, I would venture to say explaining how to debug a computer science problem, those fit under academic language. So again, as we're thinking about the ways that language shows up in our computer science classes, I want to encourage you to think about 4 different language domains as really crucial for all kinds of communication. So we have inputs and we have outputs, which of course are things that we're really familiar with in computer science. So in terms of our inputs, we're thinking about the ways that students are taking in information through listening and through reading. If those inputs are not easily understandable by our students, then they're missing out, of course, on a really important piece of the communication. Then we also have outputs, speaking and writing. If we're not supporting our students in those output methods, then they're also missing out on just as much communication. So thinking about the ways that all of our students engage in listening, speaking, reading, and writing, those are really important considerations to make when we're engaging English learners and other learners in our classes. So this was just sort of a pause and think moment. What are some social language opportunities that are present in an AP computer science classroom? And what about academic language? What are some ways that academic language is present in an AP computer science classroom? And if you're having trouble thinking of the social language pieces, that might be an indicator that we want to build some of those in to really make our classrooms as inclusive as possible of all language learners. There's one more level of academic language that I want to point out, and this is again from Jeff Zweer's research. He talks about brick and mortar terms in different subject areas. So thinking about academic language, We definitely have kind of that specific vocabulary. Those are the bricks. Things like the word reciprocal or osmosis, words like typography. Those are words that would be bolded in a textbook and definitely jump out as vocabulary that could be or should be explicitly taught. But what about mortar terms? Mortar terms are actually the terms that, the phrases that surround bricks and can be used in a variety of different contexts, but mean specific things when they're in our specific content areas. So for example, there are a few here that I wanted to point out. The term find X, that means something in math. And if we don't specifically teach students what that means, then that abstract concept can feel really confusing. Similarly, the term rounding, that is a very abstract idea that can be simplified just through some explicit teaching. Things like talking about techniques in art or graphics, of course, is something that is really specific to that context, but wouldn't necessarily be bolded in a textbook. So again, thinking back to our computer science classes, what about some bricks and mortar terms in computer science? Where would we find some of those content-specific terms? Maybe things like algorithm, maybe things like debugging. And what about mortar terms? These are more general utility words and phrases that hold together content-specific words. So I think about like, I guess debugging, I think, would also fit into a mortar term. So when I'm talking about debugging, that might mean something different for students outside of computer science. They may not have even heard that phrase, but it really does contain some content-specific meaning. I think also about phrases like following steps. What happens first and next? What happens last? I think those kinds of mortar terms that can, or phrases that can help to provide context for the real vocabulary, specific vocabulary terms are really important to think about. So I guess my point about language and these different levels of academic language and social language is that language is complex. And when we're working with students, let's not just focus in on the specific words or phrases, the vocabulary that they need to know, but let's think through the sentences and then the discourse. How do we encourage students to use the words and phrases as they're speaking? And of course, as we're thinking about computer science, this is really important because coding is really just one small part of what we talk about and what we engage in the field of computer science. Of course, there's computational thinking and there's computer science in the general sense when we're thinking about kind of the different aspects of AP classes. Looking at, abstraction, looking at data and information, looking at the internet, looking at the global impacts. There are so many ways that language helps to enrich and make meaning through each of these different topics. We want to make sure that all of our learners can access that information. So again, as we're thinking about English learners in our classes, there are some English learners that you might recognize right away because their English proficiency level is maybe more of a lower level, a 1 or a 2. This comes from the WIDA consortium, which puts out the kind of US English language proficiency standards, as well as is the organization that puts out the access test for English language proficiency, the standardized English learner test that happens yearly. So levels 1 and 2 are really beginning level English learners. Those are English learners that you notice right away and probably request help for supporting right away. As students get a little bit more developed in their English language proficiency, it might not be as obvious to you right away that they're English learners, especially because they probably have a pretty good handle on their BICS, their social language. But thinking about the ways that we need to still support English learners as they're a level 3, 4, 5, and even a 6. So I just wanted to provide this graphic to show what we can expect or what is common for each level of English language proficiency. Now, I'd like to point out that a really great philosophy, important philosophy to carry forward is the asset-based philosophy, believing that all learners come to us with important assets, contributions, and potential. And those happen through a variety of different ways: linguistic, cultural, experiential, and social and emotional. And if you're kind of needing some support to shift to this sort of mindset, I find this graphic to be really helpful. Ways that we can engage students and include their contributions in each of these different ways, instead of seeing students as having gaps or really coming to us with a lot of deficits. So I think a lot of what we do in teaching comes back to relationships, as we're all really aware. So something that I wanted to put out there is, how might we get to know our students, especially thinking about the sheer number of students that so many of us in high schools have on a daily basis. What are some strategies that you employ to get to know your students? How do you get to know what they think, what they think, what they like, what they can do in computer science? How do we best engage students on an individual or a collective level to really get a sense for how our teaching should match where they're at? I want to point out a resource as we're thinking about assets that students bring to the classroom. This is a really great video put out by Sarah Vogel and her team related to translanguaging, which means using all of the different repertoires that we have to make meaning all the time when we're encountering new information. The role of translanguaging in computational literacies is how you can find that video. So when we're thinking about language, when we're thinking about our computer science classes, when we're thinking about the sheer sheer volume of language that is happening all the time in our computer science classes, both through input and output, just curious of how you learn language best. Is there a special technique that you like to use, when you are learning and remembering a new word in your native language? How about if you're learning a new term in a new language? What if it's a technical language? When you're learning a new term or some new concepts in a new programming language, what are some strategies you use then? How might we use some of those same strategies as we support our English learners and our language learners in general in our classes? Well, I want to share a few strategies for language scaffolding in computer science, and we'll start out with input. So again, input is just the ways that students are taking in new information. This could happen through listening, this could happen through reading. And the first thing I want to say is that it's really important that learners engage with grade level content with appropriate scaffolding. So the content is still grade level, the content is still age appropriate. And instead of trying to simplify our language, what is suggested through research is that we amplify our language. So this is where we anticipate a spot that a learner might have trouble understanding what we're communicating, and we'll provide multiple ways to support them so that they can access and engage in the concepts and terms. So thinking about, if we know that we're going to use a new term as we're introducing a concept with students, we might anticipate that that could be a struggle for some students, and then provide some scaffolding. Maybe it's in the form of a flashcard. Maybe it's in the form of putting up a visual. Maybe it's in the form of talking about those words before we get started. But anticipating those moments where learners might have trouble, and then providing scaffolding and support to encourage students to be able to overcome that hurdle. Some other ways that we can support input. So many of us post content objectives in our classes. Another idea is to think about the language objectives that we want students to engage in as they're learning the content, and post those as well. And I'll show you an example in just a moment. Other things that we can do is we can activate students' linguistic and cultural knowledge that they have coming into a concept, so that we can leverage that as we're considering the impacts and the ways that those concepts show up in real life. We can do explicit vocabulary teaching, remembering our bricks and mortar concepts. And that can happen before the lesson. It can happen during a lesson. It can happen after a lesson. Sometimes teaching a word after we have common understanding of what that word means is just as effective, or even more so, than trying to teach it before we get started with that concept. Thinking about the ways that we present new information, organized step-by-step instructions that are represented in a variety of different ways, with visuals, maybe through some manipulatives or media. That includes modeling. I think sometimes in high school, we We don't always have time to do a lot of modeling, but taking the time to make sure that we are modeling concepts, even things like modeling how to respond to an AP prompt, or modeling how to respond to prompts in class can be really helpful to all learners. And that leads me to think alouds or oral processing. Math language is something that's been talked quite a bit about in the last couple of years, especially in younger classrooms. But how might we engage students in think alouds in computer science classes as well, to really encourage them to produce that or have output in that academic language of computer science? And then connecting to analogies and real world context, really having other situations and scenarios that include concepts that we're teaching helps to provide resource and further understanding for students who might be new to computer science. So here are some content and language objectives, just to give you a little bit of an idea of what those can look like. So if the content objectives are things like students will investigate the elements involved in designing a web page, and they'll develop a model web page for a particular topic or theme. Those are content objectives. Those are things you're probably really familiar with. The language objectives involved in each of those might include things like students will list the steps for setting up the layout, background, and color scheme for a model web page. And then how about students will orally present their model web page on a particular topic or theme? So this is, again, thinking of ways that students will engage with those content objectives through language. And in specifics here, this is talking about their output of language related to each of those concepts. When we think about explicit vocabulary strategies, I think we all probably have different ways that work for us, or different ways that we have practiced explicitly teaching vocabulary. And one way that has worked really well for me, one of my favorites, is the Freyer model. This is a modification on the Freyer model that I have used with my English learners at my school, and I've found to work really well. So it's got the definition, it's got using that word in a sentence in context. It's got places for examples where they would see or hear that word, a visual that they can include there, and then connections to the real world. What does this make you think of? Where have you seen this before? What does this mean to you? And then what are related words that you don't know? So as students are looking up the definition, they can include their other words that they're not sure of, so that they can look those up later or ask somebody. I've often included under the definition or under examples a place for students to also include what this word would be in their home language or in their L1. And this is another way to help provide context for other students. So if one student knows that word in their home language and there are other students in the class with the same home language, having that student share out if they feel comfortable doing that can help bring other learners along, kind of in deepening their understanding of what that word is. Here are some other supports for input that I think are really helpful. Things like manipulatives, pictures and photographs, things like videos and films, and then thinking about graphic organizers. Maybe there are some graphs or timelines. Maybe you're working in some really specific collaborative pairs. Maybe you're using a home language like what we just talked about, or there are some mentors. So this is an opportunity to reflect for a moment on how these things related to input supports can connect back to mobile CSP and CS Awesome. Are there some supports for input that already exist? And if so, what are they? And to follow that up, where might some additional supports for input be needed? Is there a place that's especially text heavy and where reading might be really challenging for students who are still early on in their English language proficiency? What supports might you consider adding? Are there some that I've mentioned here or others that occur to you now that could be really helpful? So now that we've covered a little bit about input, let's talk about output. Again, output is where students are producing language, whether through writing or speaking, in order to communicate their ideas. And what we really want to focus on here is that they're communicating academic language. So something that's really important is that learners have repeated, strategic, iterative, and supported opportunities to express these ideas. So it's not just one time, it's not just done kind of haphazardly, it's done in a repeated way where they're able to kind of assess and then improve upon their process and their output, and then where there are supports in place. And so what are some of those supports? Well, there are different parts of language called language functions, and they align pretty closely to higher order thinking skills. So thinking about how we ask students to produce output, we could differentiate the different language functions based on the language proficiency levels of students. So for asking students who are fairly new in their English language proficiency to express a concept, we might ask them, instead of, for example, defining the concept, we might ask them to classify things that are alike. We might ask them to put things in order. And then as they get more developed in their English language proficiency, that's where we can start to ask them to do some higher order thinking, like analyzing and inferring and justifying. Throughout all of those different language functions, it's always important to consider including sentence frames as supports. You might have flashcards. You might have an interactive word wall where students can refer up to a place in the room where common words and phrases can be found. Maybe there are placemats at their desk that they can write on. Maybe there's shared notes documents or written shared notes. Multiple forms of output is really great, not just thinking about writing and speaking, but also visuals, and offering those as choices to all students, because of course all of our students need support in different ways. Structured notes through things like graphic organizers, structured collaboration, so really thoughtful pairing and thoughtful group work, and then feedback and continued practice. So let me give you a few examples of those. I mentioned the academic language functions, and when I'm talking about those, again, that's things like seeking information. You can see them on the far left there: seeking information, informing, comparing. I do have a link to this PDF so that you can check out kind of the whole range of them. But you can see here that this resource offers how the student would use that language. So for example, with seeking information, they're using language to observe and explore. Here are some examples of how they might use that. So it's like a who, what, when, where, gather information. There are some graphic organizers or thinking map ideas there, as well as some language structures and key signal words that you might want to pre-teach or provide support for. So if students are seeking information, they might need to know the verb to be. They might need to know some action verbs and some prepositions. And that is something that an EL teacher can help you to kind of dive into how to support. And then there are some tasks there. So as you're thinking about what kinds of language objectives to write with your content objectives, you might include words like define or draw or label, matching, selecting. Those are academic language functions that can be written into language objectives as you're asking students to engage with the new content or with the content for that day. And then there are some questions that you can include there, and later on there are some sentence frames. So I mentioned sentence frames. Here is one specific one that comes from Mobile CSP. So one of the prompts in one of the Mobile CSP lessons says, how do the internet and cloud applications impact our society positively and negatively? And you and I might have kind of our response primed and ready to go for that. But for students who are language learners, again, whether ELs or other students who just need some language support, sentence frames can be really helpful. So breaking it down even just to one positive way that the internet and cloud applications impact our society is, and then one negative way that the internet and cloud applications impact our society is, breaking it down even just into those two sentence frames can be helpful in encouraging students to frame their thoughts and to know how to then produce the output to explain their thoughts. Another activity that can be helpful to strengthen or support oral language output is something called Stronger and Clearer. So this is where students are sharing their opinions or ideas about a concept, and they're going to borrow some ideas and verbiage from others as they reformulate their thoughts. So here's how it works. If we ask students to think about that same question, how do the internet and cloud applications impact our society positively and negatively, what we'd have them do is first write down their initial idea. Just take a moment by themselves. Then we'd have them talk to a partner and write down one thing that their partner says in their answer. And their partner would do the same. Their partner would write down one thing from their response as well. Then they would use their partner's information to expand on their own answer. So kind of building on the information that they included in their answer and adding in some new ideas and new verbiage from their partner. And then they would talk to their new partner using that now elaborated answer. So this is a way to really fortify the oral language output and to build on some vocabulary and language structure using other peers as models. So those are a few ideas for output support. And now pausing again to think about mobile CSP and CS Awesome, what are some supports for output that already exist? Are there some ways that language is supported, language production, language output is supported? Or are there some places that additional supports might be needed? And if so, which supports might you suggest using? Are there some we've mentioned here today or some others that you've got in mind that would be especially helpful to students as they're producing new language? So I have just a couple other points that I wanted to mention, and these are things that I think especially come into play with computer science classes. So one of them is related to creating routines and opportunities that are structured peer conversations. So this allows students to make and communicate meaning. It allows them to learn from one another. They have an authentic audience. They feel like they're communicating with purpose. Something like pair programming is an excellent example of structured peer conversation because each student has a role, and there are also certain kinds of language that we can support students in producing in pair programming. These kinds of situations really do help students to know how to navigate real-life communication scenarios. It's great practice for that. How often in life do we get to practice what we're going to say before we say it? Not often, but we can create those scenarios through really structured peer conversations. We can also then provide some scaffolding for language functions so that students feel supported as they're working with a partner. And then that way they can feel comfortable not only working in a smaller group, but eventually sharing out with the whole group. So I mentioned one collaboration routine is pair programming. So we've got the driver role and we've got the navigator role, and encouraging the driver and the navigator with specific phrases that they might say. So for example, the driver might say, "What do you think we should try next?" And the navigator might say something like, "Oh, well, I noticed that our project isn't quite doing X, Y, or Z thing that we had planned. Maybe we should try," and they fill in the blank with the next thing that they have in mind. But providing some of those ideas and language structures so that students can fill in with their own ideas in supported ways, I think can be really helpful. I also wanted to provide an idea here. This is one way that I structured debugging. So when we do debugging in one of my classes, we use partners to help talk through where the problem comes up. It's sort of like a real life version of rubber ducky debugging. So in this case, we've got partner A and partner B, and partner A has specific things that they say, and partner B has their own specific things. So can you tell me what you wanted your program to do? And partner B says, well, it was supposed to do blank, but instead it is blank. In this way, partner A and partner B have kind of a set script that they can follow so that they can channel their ideas into really productive conversations. The final idea I want to bring up is around meta awareness. Students will say, "Oh, that's so meta." So this is where we're thinking about our own thought processes or our own language use so that we can really explicitly call attention to what we're saying or what we're thinking. So asking students to process through, what method did you use to debug this? How did you overcome this challenge that you were talking about? How does this new thing from that we talked about yesterday, how does that connect with what we've talked about today? What's still confusing you in our lesson? Encouraging students to really reflect. And one thing that I do to help that is something called gathering and showing student discourse. So as students are working together in pair programming, I like to go around and just jot down phrases that I hear. And I'm always so impressed with the ways that academic language shows up in their real lives, in their real conversations. What I do then is, as I am gathering that intel, that data, I'll gather it on sticky notes and I'll post that up on the wall in sort of a living word wall so that as students are producing academic language, I'm writing it up as a resource, and then they can later refer back to that and they can use that in future conversations as well. Sketches, diagrams, visuals can also be used to capture some of that meaning, and that's something that students can do as they're hearing and making sense of the academic language around them. I talked a little bit about how math talk has gotten a lot of really great, or number talks has gotten a lot of really great attention. And so thinking about ways that we could channel a similar idea into computer science talk. So maybe there's an independent think where students get a programming problem that they could solve with a computer. They just have to think about it first for 1 to 2 minutes. They pair up, and then they do a pair share, and then they do a whole class share out where they can share the method or the strategy that they would use to solve the problem. And then again, let's capture those ideas, and then let's display them in a way that we could reference again and again for future use. So I'm going to pause again and just think about how might we apply these to mobile CSP and CS Awesome. So again, this is talking about really structured peer conversation and thinking about meta awareness. What are some ways that those are already present in mobile CSP and CS Awesome? Where might be some new areas that we could infuse mobile CSP and CS Awesome with structured peer conversation and meta awareness? And what are some strategies you might use to do that? What are some of the maybe methods that we've talked about that really resonated? The last one I wanted to talk about, and I would argue one of the most important, is culturally relevant pedagogy. So really thinking about ways that student agency, voice, and choice show up in your classroom. Thinking about ways that students' own sociocultural linguistic backgrounds show up. How are we inviting students to use all of their meaning-making strategies to help them to understand new concepts, and then to share out about that, so that we're not just asking students to make meaning for themselves, but to make meaning that they can share. This, in turn, helps us to draw from students' own knowledge and context, and just by proxy makes the learning feel more relevant, more authentic, more enriched, I guess, with the interests of our students and the experiences of our students, and can also then draw in a variety of different influences, things like families, community, representation in a variety of ways, thinking about relatable role models. I shared a story in this previous presentation here where one of my computer science classes included quite a few Somali male students. And one of my students, as we were thinking about computer science identity, says, I don't even know why I chose to take this class. I don't know of any Somali computer scientists. There probably aren't any. This is not really probably for me. And so what I did with that student is we actually started doing a little bit of research. And we found a guest speaker who could come and speak to us about entrepreneurship and the UN Sustainable Development Goals. And she was a Somali refugee, and she's using both entrepreneurship and the UN Sustainable Development Goals to develop an app. And that, to me and to that student, was like a really awesome way that we could find a relatable role model who, I didn't mention this, but who lived just a few miles away from where this student grew up. So again, thinking about ways that we can work together with students to find role models that are representative and relatable to our students is really important. And then finally, authentic context. How are we applying the computer science principles and practices that show up in our classes to real world social justice contexts? So things that have meaning for students and things that make an impact. I find that my students get excited about the problem solving, and they get excited about the puzzles and the critical thinking involved in just classroom-based examples of computer science, but where they get really passionate is the outside connections that computer science can have in their real world, and inviting them into that process through social justice lens has been really powerful. So one last pause to reflect. So again, how might this apply to mobile CSP and CS Awesome? Where are culturally relevant practices already included? And where might there be some room for additional culturally relevant practices to be added? And then do you have some ideas? What would be a few culturally relevant practices that you could include? So to sum up, we're finishing up here. We've talked a little bit about how support for English learners and many others is really important in computer science, and that's because language is so complex. Computer science is actually really language rich, thinking about the academic language that's involved, both the input and the output. We want to make sure that we're using an asset-based viewpoint when we're thinking about students and the things that they have to offer to our classes. We want to include content and language together. Neither can really be seen as a separate entity. They work together in tandem to form meaning and to express understanding. And because of that, we want to be sure that we're offering lots and lots of linguistic scaffolding and support to our students through the supports for input, output, collaboration and practice, and then meta-analysis that we talked about. And finally, always being mindful to include culturally relevant pedagogy. I just wanted to show that I've got some resources here if you wanted to follow up on any of the information that we talked about here. And again, I just wanted to thank you. This has been really exciting to share with you some of the ideas and resources that I have found and that have proven really helpful for me in supporting English learners. And I would love to hear from you about what works for you. Sorry to make you dizzy. I'm just going to scroll all the way back up to the top so you've got my contact information. Feel free to reach out at any point if there's anything that I can do to support you or to support your work, or if you have questions or new ideas to share. If I flubbed up and made any mistakes, I'd love to hear about it so I can make sure to correct that for future presentations. And thank you again for your time. I'll leave you back up on our slide here and take care. Thanks again.